This is lesson 10.2, simplifying radicals. Your objective is to simplify radicals involving products and quotients. Vocabulary. Radical expression is an expression that contains a radical. Here are some examples. Rationalize the denominator. To rationalize the denominator of an expression, rewrite it so there are no radicals in any denominator and no denominators in any radical. Here's an example of what we'll be doing in this lesson. You can simplify radical expressions using multiplication and division properties of square roots. First property, multiplication property of square roots. For a greater than or equal to 0 and b greater than or equal to 0, radical ab, the product of a and b, equals radical a times radical b. For example, we have radical 48. This is equal to the radical of 16 times 3. Using the property of square roots, we can split this up as radical 16 times radical 3, and we know that the square root of 16 is 4, so that'll simplify to 4 radical 3. You can use the multiplication property of square roots to simplify radicals by removing perfect square factors from the radicand. Problem 1. Removing perfect square factors. What is the simplified form of radical 160? We know that 160 is equal to 16 times 10. There are other factors that we could use, but 16 is the greatest perfect square factor of 160. We're going to use the multiplication property of square roots and rewrite this as square root of 16 times the square root of 10. And we know that the square root of 16 is 4, so we can simplify square root of 16 as 4, and then we leave the square root of 10. Removing variable factors. What is the simplified form of radical 54n to the 7th power? Well, we know that 9 times 6 will give us 54. To split up n to the 7th power, we're going to use n to the 6th and n, because we know that n cubed, when we square it, will give us n to the 6th power. So 9n to the 6th power is equivalent to 3n cubed squared. We're going to use the multiplication property of square roots to split these two factors up. Then we're going to take the square root of 9n to the 6th power, and we get 3n to the 3rd power, and we leave radical 6n. Problem 3, multiplying two radical expressions. You can use the multiplication property of square roots to write radical a times radical b as radical ab. What is the simplified form of 2 radical 7t times 3 radical 14t squared? Well, we can multiply the whole numbers and use the multiplication property of square roots. So 2 times 3 will give us 6 outside of the radicand. And then underneath the radicand, we can multiply 7t and 14t squared. We can multiply those two together to get 98t cubed under the radical symbol, and the 60 is on the outside. However, this can be simplified underneath the radical symbol. So we look for the greatest perfect square factor, which is 49. So 98 gets split up into 49 and 2. T cubed will split up as t squared and t. So the factors will be 49t squared times 2t. And using the multiplication property of square roots, we split those two up. And then we take the square root of 49t squared, which is 7t. And then we can't do anything with the 2t, so we're going to leave that. And then we simplify the numbers outside of the radicand, and we get 42t times radical 2t. You can simplify more radical expressions using the following property: the division property of square roots. For a is greater than or equal to 0 and b is greater than or equal to 0, radical a over b is equal to radical a over radical b. For example, we have radical 36 over 49. We can split these up as radical 36, or rewrite them as radical 36 over radical 49, and we know that the numerator is equal to 6 and the denominator is equal to 7. When a radicand has a denominator that is a perfect square, it is easier to apply the division property of square roots first, and then simplify the numerator and denominator of the result. When the denominator of a radicand is not a perfect square, it may be easier to simplify the fraction first. What is the simplified form of each radical expression? So we have radical 64 over 49. We're going to rewrite this as radical 64 over radical 49 using the division property of square roots. And we know that radical 64 is equal to 8, radical 49 is 7. Now this one is a little bit more complicated because of the variables. We have radical 8x cubed over 50x. We're going to rewrite this as radical 4x squared over 25, because we notice that the numerator and the denominator have a common factor of 2x, and none of these numbers in here, well, the 8 and the 50 are not perfect squares, but once we simplify the fraction, we get 4 over 25, and those numbers are perfect squares. Also, we can simplify the x cubed over x by dividing it by x, and we get x squared in the numerator. Now we can use the division property of square roots to rewrite this as radical 4x squared over radical 25. We can also apply the multiplication property of square roots to split up that the product in the numerator, so we can write radical 4 times radical x squared over radical 25. And we know that the square root of 4 is 2, square root of x squared is x, and the square root of 25 is just 5. Problem 6, rationalizing denominators. When a radicand in a denominator is not a perfect square, you may need to rationalize the denominator to remove the radical. To do this, multiply the numerator and denominator by the same radical expression. Choose an expression that makes the radicand in the denominator a perfect square. It may be helpful to start by simplifying the original radical in the denominator. So here we have radical 3 over radical 7. None of these are perfect squares, and we cannot leave a radicand in the denominator. So we're going to multiply both the numerator and the denominator by radical 7. And when we simplify this, we get radical 21 over radical 49. Now I can take the square root of 49 and simplify that to 7 to get rid of that radicand in the denominator. And the radical 21, I can't do anything with that, so we leave it as is. Here we have radical 7 over radical 8n. 8 is not a perfect square, but we do recognize that it has a factor of 4 that is a perfect square. So we're going to use the multiplication property of square roots to separate 8n as 4 times 2n, and then the square root of 4 would be 2, so on the denominator we have 2 radical 2n, the numerator we still have that radical 7. Now we can't leave that radical in the denominator, so we multiply both the numerator and denominator by radical 2n. When we do this, in the numerator we get radical 14n. The denominator we get 2 times the radical of 4n squared, which is a perfect square, and that will become 2n, but when I multiply it with the 2 on the outside, I get 4n in the denominator.